Hi, welcome back to Circles Part 2, Lesson 5, Arc Length and Sector Application Problems. So let's jump right in. We are not learning a new concept, a new formula. We are just working on some application problems based on sector area and arc length. So this first page has 5 problems on it, so we're going to run through these together. Okay, a pie is cut into 6 equal pieces. The arc length of one piece of pie is 5.4 centimeters. What is the diameter of the pie? Okay, so our strategy is always to draw a picture. So let's start by drawing a picture of the pie, and we're assuming it is a circular pie, and 6 equal pieces. Let's see, cut it in half and then divide that out into 6 equal pieces. Well, if we have 360 degrees divided into 6 equal pieces, our central angle is going to be 60 degrees. Okay, so that kind of gives you an idea of what we're working with, 60 degrees. We also know that if it's cut into 6 equal pieces, each piece represents 1/6 of the circle. Okay, so what we're going to do is we're going to use that proportion method that we used earlier. Okay, do you remember the proportion method? It works like this. We take the arc length, if we know it, and we put it over the area. I'm sorry, this is not an area problem, it's over circumference, because arc is part of the circumference. And then we put our measure of the angle over 360. So let's plug in what we know. We know the arc length from this problem is 5.4. So plug in 5.4. And circumference we don't know. So that's x. And then angle measure, we just decided it was 60 degrees, didn't we? And 360 is the total of the circle. So now you can look at this, and this reduces down to 1/6 because it's 1/6 of the circle. Now let's do cross products. So we get 1 times x, or just x, and then 6 times 5.4. So I'm just going to grab my calculator and do 6 times 5.4, and I got 32.4. So 32.4 is actually equal to my circumference, because x is equal to circumference, right? That was what was here. Now we've got to work backwards to answer the question and find the diameter. Circumference is equal to d times pi, which is 32. So all I did was plug in d times pi, divide both sides by pi. So I'm going to take 32.4 and divide it by second and the exponent key right here, which is my pi button, and I get 10.31. So that means my diameter is 10.31. And there we go. And that's how you work that problem backwards. So that would be the diameter of the pie. So if we had to write a sentence, we would say the pie's diameter is 10.31, and that was in centimeters. And that's how you could answer that question in a sentence. Okay, so that's number 1. Let's look at number 2. Number 2 is a question about a circular track. Okay, Miss Noonan walked 4 times around a circular track that has a radius of 40 meters. What is the total distance she walked? Okay, so the first thing we want to do is draw a picture. So let's draw a circular track, and it said that the radius was 40. So let's draw in 40 meters. And what we've got to do is find that distance around, because she's walking. So that's going to be our circumference. So we're going to use the d times pi formula to find the circumference of the circle. So our diameter is not 40, but remember it's 80, because we have to double that. So it's 80 times pi. But she didn't walk once around the track. How many times did she walk around the track? She walked 4 times around the track. So 80, 160, was that 240, and 32. Okay, so we're going to multiply by 4 and we get 320 pi meters as our answer. So there's our answer. And in this problem, you may, since it's a word problem, you may want to go ahead and multiply it out. So I'm going to go ahead and take 320 times pi, and I get 1,005.3 meters. 1,005.3 meters. And the reason I'm doing that on this problem is because this is an application problem and we want it to have some meaning. So she walked a little over 1,000 meters. So Mrs. N walked 1,005.3 meters. And we're done. So there you go. That's how you would do number 2. Okay, let's jump on to number 3. Number 3 is a clock problem, and I really like these clock problems. So we've got a picture up here, so let's kind of read through it and see how this kind of makes sense. Okay, how many degrees does the minute hand move in each set of minutes? So we've got our circle, our clock is the circle, and in 30 minutes we go from directly on the top to directly on the bottom, or 1 to 7 or 2 to 8. So we're going halfway around the circle. So that one's actually really easy. What's halfway around the circle? Well, halfway around the circle is 180 degrees. Okay? So that one we can do just kind of logically thinking about a circle. But then when we start getting, well, 60 should be pretty easy, shouldn't it? If you go 60 minutes, how far does it go? It goes all the way around, so we know a circle has 360 degrees. But for 40 minutes, it's a little trickier. We might need to know how far the clock moves in 1 minute. So from 12 o'clock to 12:01, how many degrees does the clock move? Well, think about it this way. You've got 360 degrees and you have 60 minutes, right? So each minute the hand moves 6 degrees. So it's going to move 6 degrees per minute. So in 1 minute it's 6 degrees. In 2 minutes it's 12. In 5 minutes it would be 30. So we just take 6 times the number of minutes, okay? Which, let's test one, okay? We know at 3 o'clock the hand would be up and then over to the 3. Well, that's 90 degrees. So that's 15 minutes times 6, 90 degrees. Okay, that works. So we're just testing our pattern and it does work. So let's go back to the 40 minutes. 40 minutes, 6 degrees per minute. 40 times 6 is 240 degrees in 40 minutes. So that's how you would do part B. Okay? So you may want to remember the rule as 6 degrees per minute. Okay. Now let's look at the next one. If the minute hand is 4 inches, find the area of the whole clock. Okay, if the minute hand is 4 inches. Okay, the minute hand is the longer hand, isn't it? So what are they really trying to describe to us? The minute hand would represent the radius. So we're saying the radius is 4 inches. What is the area of the whole clock? Well, area is pi times radius, which is 4 squared. So 16 pi inches squared would be our area. Okay? What would the circumference be? Well, circumference is what formula? D pi. And if our radius is 4, what's our diameter? 8. So we're going to plug in 8, stick a pi next to it, and stick inches next to that. So it's 8 pi inches. And if you needed to know the more application part of that, you just take 8 times second arrow, which is pi, and we get 25.13. So that final answer would be 25.13 inches. Okay, so there's number 4. Now let's look at number 5. Number 5 says, if the minute hand is 4 inches, find the area of the sector created by the hands of the clock at 2 o'clock. Okay, so we actually have to take the information from 3 and 4 and put it together. So we're looking at the same clock that we were looking at earlier. We've got a circle, we've got a radius that is 4, and we're looking at 2 o'clock. Okay, so we need to know this angle measure to be able to figure out the sector area. Because remember, sector area is the measure of the arc over 360 times pi r squared. So that's our sector area formula. So whoops, let's zoom out a little bit. There we go. So there's our sector area formula. So we need to know the measure at 2 o'clock. Well, 2 o'clock covers 10 minutes, right? That's 10 minutes, which is how many degrees? Well, we said each minute represents how many? 6 degrees. So 10 minutes times 6 degrees per minute, that gives us 60 degrees. Okay, so it's 60 degrees over 360 times pi r squared. Well, we just figured out our area in the previous problem. So we've got 16 pi as our area. So I'm going to just plug in 16 pi. So what's 1/6, because this reduces to 1/6, times 16 pi. Stick a 1 underneath that. That gives us 16 pi over 6, which is what? 8/3 pi is our sector area. If you need to put that into decimal form, we take 8 divided by 3 times second function caret to get the pi, and it gives us 8.377 or 8.38 if we round to the closest hundredths. And that's going to be in, what unit is that? Inches. Inches squared. Area is always squared. There you go. So that is how you would figure that problem out. So you're looking, using your formulas, deciding what you need. Always draw a picture. That's first strategy. Draw a picture, label it, write your formula, and plug in what you know. Those are good practices. Okay, let's look at the second page. The second page is all multiple choice, and these are great practice problems because as you prepare for the SAT standardized testing, you get some good practice. So we try to throw in quite a bit of multiple choice questions throughout the year so you can practice these, because if nothing else, you learn a little bit about just elimination. It's always refreshing too when you read a problem and you see your answer as one of the choices. Okay, so let's look at number 1 up here. It says use circle O for questions 1 and 2. So here's our circle. We have an arc MN, we have a 54-degree central angle, and our radius is 10. So kind of evaluate what you have when you start. What is the length of MN? Okay, so we have to decide, am I using arc length formula or am I using area formula? Well, it's asking me for the length of MN, which is arc length. So let me write my arc length formula down. Arc length is the measure of the arc over 360, and an arc is part of the circumference. So it's going to be times d pi, okay? And we could stick that over 1. So what was our arc measure in this one? Our arc is 54 over 360 times diameter. Well, our radius is 10, so our diameter is 20. So 20 pi over 1. Now it's just a matter of cleaning that guy up. Okay, so a couple ways to do this, and I'm going to show you, some calculator skills right now. We're going to take 54 divided by 360. Okay, that's going to give me a decimal of 0.15. Let's say I don't want that decimal. I want to know what the reduced fraction is. I take and I hit my math key, and I choose the very first choice. Change it back to a fraction. I enter it twice, and voila, it's 3 over 20. So I can make this 3/20 times 20 pi over 1. Ooh, this is nice. When you multiply straight across, but we can also reduce, can't we? We've got 20 on top and 20 on the bottom, so that cancels out 1 and 1. So we get 3 pi over 1, or just 3 pi. So that's my answer. So, looking at our multiple choice, of course it is B. Choice B is our arc length. Okay, so let's look at number 2. Number 2, we're using the same diagram, but we've got to find the shaded area. Okay, so now we're finding area. So are we going to use the arc length formula or sector area? Well, sector area. So we're still going to do the measure of the arc over 360, but instead of multiplying by circumference, we're going to multiply by the area because we're finding the fraction of the area. Okay, so we need the radius. Well, the radius is given as 10. So, and we know that the arc is 54. So 54 over 360 times pi times 10 squared. Okay, we learned a minute ago by using our calculator, this reduces to 3/20 times 10 squared is 100 pi over 1. Now I can do some cross canceling again, can't I? Remember, we would normally just multiply across, but I can reduce. So I'm going to take a 20 out of that, and 20 goes into 105 times. So 3 times 5 is 15 pi all over 1, or just 15 pi. And that's in what, yards squared, because that's area, and that's always squared. So let's look, and yes, that's one of our choices. Number 2 would be A. Okay, so let's look at number 3. Number 3 says, what is the length of GAH? So we're looking for the length of an arc. So are we finding part of the circumference or part of the area? Well, an arc length is part of the circumference. So we're going to use our circumference formula. The measure over 360 times circumference is d pi. Okay, so let's plug in what we know. Our measure is 135 over 360 times the diameter. Okay, well, let's look and see what we have here. We have 16. Is that our diameter? No, that's our radius. So if our radius is 16, our diameter is what? 32. So plug in 32 pi over 1. Now let's do a little cleaning up. Again, let's work on that fraction. I'm going to take 135 divided by 360, and I get 0.375. I want the fraction, so let's go to math. Fraction, enter, enter. Voila, I get 3/8. So this reduces to 3/8 times 32 pi over 1. Now I can clean this up. I can take 8 divided by 8 is 1. 32 divided by 8 is 4. So 3 times 4 is 12 pi. Okay? So that one is 12 pi, and voila, there it is. It is one of our choices. It is choice C. So that would be, oh, not C, choice B. B is 12 pi. Okay, we got 3 more to go. So let's look over here at this problem. Okay, the next 2 problems use the same diagram, and this is quite an interesting diagram. Okay, we first have to find the length of QR, and it says the approximate length. We don't have an angle here, so I'm going to assume that it's 90, and since it says approximate, we can make that assumption, even though we really shouldn't from that diagram. But based on this diagram, that's what we're going to do. So we're going to try to find the arc length of QR. Okay, now for arc length, remember arc length is the measure over 360 times circumference, which is d pi, and we're going to assume that that angle is 90 degrees, so the arc would be 90. And we know that 90 over 360 reduces to 1/4. Okay, our diameter is given to us as 14. So let's plug in 14 pi. So 14 pi times 1/4 gives us 14 pi over 4, which reduces to 7/2 pi. Let's see if that's one of our choices. 7/2 pi isn't, because this is an exact and we're looking for approximate. So let's do a little work on the calculator. I'm going to take 7/2. 7 divided by 2 is 3.5 times pi, second an arrow, and I get 10.99. Okay, now we can look at our answers. Which one would it be? It would be A, 11. So this is 10.99, which is approximately 11 meters. So it is choice A. Okay, so there's number 4. Let's move on to number 5. Okay, number 5 asks us, let's see, what is the approximate area of the shaded region of circle X? Okay, this one is going to be a little trickier than any we've done before. So I'm going to teach you a little strategy on this one. Okay, what we've got to do is we've got to find the area of the whole shape. In this case, we're going to find the area of the circle. But we're going to have to remove or take out the area of the unshaded, which is just a triangle, isn't it? So I'm actually going to turn this on its side so you can see it more as just the triangle. Okay? So we're going to find the area of the circle, and we're going to subtract the area that is unshaded, and what we're going to be left with is the shaded region. So I always like to draw these as this. I like to take the outer shape, which is a circle, and I like to write down formula, and then I'm going to subtract from it a triangle. Okay, now what's the area of a circle? Pi r squared. What is I'm going to draw this a little bit bigger so I can put my formula in it. What's the area of a triangle? It's 1/2 the base times the height. Now all I have to do is identify my variables and plug them in. Okay, so let's go back to our diagram and see if we can figure out the radius and the diameter, or the radius, the base, and the height of the triangle. Okay, here's our picture. So what's the radius of the circle? Well, we know the diameter is 14, so the radius must be 7. So I'm going to take pi times 7 squared, and I'm going to subtract from it 1/2 the base times the height. So let's look at this triangle. What is the base of that triangle? The base is 14, and what's the height? The height is the radius, isn't it? Well, we know this is 14, and what's our radius? 7. So we're going to take 1/2 of 14 times 7, and that gives us the area of the triangle. So 1/2 of 14 times 7. So we get 49 pi minus half of 14 is 7. 7 times 7 is 49. So we have 49 pi minus 49. Is that one of our choices? No, because this says approximate. So let's grab our calculator and get an approximate value. So I'm going to type in 49, second function, caret key to get my pi, minus 49. Notice I can put it all in at one time. Enter, and I get 104.9. 104.9. Now let's go back to our choices. Which one is the best choice for this? 105 meters squared. Meters squared, because this is area. So the choice would be D for our best pick. Okay? So D is the answer. Okay, let's look at the very last one, number 6. And you'll be doing lots more of those shaded area problems throughout the school year. You're going to be doing other shapes inside of shapes. I really like those. Okay, let's look at number 6. A sprinkler system shown below has a spray of 15 feet. Okay, so if we look at this as a circle, what does that 15 feet represent? Our radius, right? And it's set to rotate 100 degrees. So from edge to edge, you know how the sprinkler goes. Okay, so it's shooting 15 feet and it's spanning 100 left to right. Okay, what is the approximate area of grass that will be watered by the sprinkler? So we're looking for area covered by the sprinkler. Well, is that arc length or sector area? Pretty easy. Sector area, right? So number 6, let's do our sector area. You got the measure over 360 times area, which is pi r squared. Okay, so our measure is 100 over 360 times pi, and what was our radius again? Our radius is 15. 15 squared. So let's do some reducing. Cancel out our 10s, divide by 10, and then I have 10 over 36. That reduces to what? 5/18 times, and then 15 squared is 225 pi. Stick a little 1 underneath it, and we can clean this up. Now, these answers are approximate. So I'm going to go ahead and put this in my calculator, just like it looks. So I'm going to put in 5/8, and to put in 5/8, what do? You do 5, whoops, let me clear my screen. 5 divided by 8, okay? Then we're going to go times, and in this case we have 225 pi. So I'm just going to put in 225 second and get my pi key, and once I hit equal, we should have the answer, 441.78. So 441.9. And let's look at our choices. What would that be? There isn't one, is there? I don't see an answer here. So I have either done something wrong or the answer is not on here. Did I put that in the calculator? Oh, I forgot to divide by 18. I did 5/8 instead of 5/18. Let's try that again. 5 divided by 18 times 225 pi. See, even teachers make mistakes. Okay, 196. That sounds a little better. 196 feet squared. Don't we love multiple choice? We find our own mistakes. There we go. So it's choice number C. And there we go. So there's your video. I hope these application problems make sense to you. Remember, you're using one of 2 formulas. You're going to use for arc length the measure over 360 times d pi. And that is your arc length, which is part of the circumference, right? Part of the circumference. If you're going around the edge of a circle, edge to corner, just part of the curve. And then if you're finding sector area, I always think of that as our slice of pizza. Well, area is pi r squared. That is sector. And you can call it sector or sector area. And that's like what slice or what is our area in that circle. So read the problem. So let's review real quick. What are your strategies? 1, read the problem. 2, draw your picture. 3, label any information. And then you're going to choose your formula, correct? Choose the formula that you're going to need. And then you're going to plug in any variables. Now, I just went over 2 formulas, sector area and arc length. But if you have to do one of those backwards problems and maybe find the radius or maybe go back and find the diameter, you can use the proportions. So let me summarize the proportion formula one more time. You're going to have the measure over 360. Okay, so that's always dealing with the measure. And then for arc length, you're going to have arc length over circumference. For the other one, if you are dealing with sector area, you're going to do the measure over 360. So these two parts are always the same. Is equal to the sector area, right, over the whole area, which is just pi r squared. And this one would be d pi. Okay? So hopefully those proportions and those formulas will help you get through all your application problems. Good luck!